and acceptance.
Hello, and welcome everybody to this Micronaut 3 and GraalVM deep dive. So this is a longer form talk where we will spend 2 hours going through in a lot more detail what Micronaut is, what GraalVM is, how they work, and hopefully get more time to explain some of the ins and outs of these great technologies. And for those of you who don't know about me, my name is Graeme Rocher. I am an architect at Oracle Labs. I've been at Oracle Labs since 2020. But I've been I guess you would say, professional open source engineer, I guess you would call me that, since 2007. So I created another open source framework called Grails. I'm not sure how many of you heard of Grails, but it's been around a long time. And more recently, Micronaut. That work on Grails was the reason for the 2018 Oracle Groundbreaker Award. If you want to connect with me, I'm available on social networks. Twitter, LinkedIn, GitHub, whichever one you prefer, and always happy to chat. We also have a Gitter chat channel where you can come chat to me, and afterwards. And of course, we'll do Q&A at the end. So we are going to have a pretty full agenda today. We will talk about, do an initial introduction to the Micronaut framework and what it is, and go through some of the fundamentals, how to test it, and so forth. And we will also basically go through some of the key concepts, such as configuration management, dependency injection, etc., the basis of how it works. That's kind of the first part. And then in the second part, we will go through Micronaut AOP, which is the basis of a lot of how the more dynamic features in Micronaut work. And we will look at an implementation of Micronaut AOP and the bean validation support. We'll look at bean events and listeners. We'll look at the Micronaut HTTP server, the HTTP client, how those work. We'll then shift focus onto GraalVM and Micronaut's relationship with GraalVM, how GraalVM works, how to build native images, how to deal with cases of when reflection is required in your application, how to package Micronaut into different formats for deployment into production environments, whether it be a runnable jar file, a native image, a Docker image, and so on. We'll also look at Micronaut serialization, which is relatively new, building open API specifications. And then we will go on to looking at Micronaut data. Now, some of you may have been in my talk yesterday, where we looked at Micronaut data, but we'll go through Micronaut data and relationship, and then we'll have time. And depending how the pacing on how we're doing, etc., we may have to cut short something or expand on something. Getting the pacing of a 2-hour talk is a lot of fun. So, and we'll have summary and Q&A. So to start off with, we're going to start with part 1 of this talk, which is the introductory material. So how many in the audience have actually heard of Micronaut? Okay, a few. And GraalVM? A few. Okay, good. So we'll talk about now an introduction for those who haven't. But basically, the origins of Micronaut were based on my work when I worked at VMware and SpringSource and on Grails, where when you work on framework internals, you realize the limitations of the existing Java virtual machine when it comes to evaluating the way a framework works at runtime. So you have to deal with the fact that we have annotations in Java, but there is very little support in Java to represent meta annotations and compute annotations that are on supertypes and in interfaces and combine them. And even the way repeated annotations work, because they were added later, is a bit of a kludge. Because basically, if you have a repeated annotation and it appears once, it appears as the non-repeated version. If you have it and it appears twice, it appears as the repeated wrapper. And they did that for backwards compatibility, but it makes it very complicated for frameworks to deal with. There's things like type erasure. There's things like reflection, which has historically been slow. It's actually fixed in the latest version of Java because they moved reflection to use method handles. But it's still slow to evaluate reflective data at runtime, because if you have to do a lot of analysis of a lot of reflected data, you have to load all that reflective data, you have to traverse over it, you have to inspect it. So it's still pretty low and slow, and then it impacts memory because of the use of reflective data caches. A lot of frameworks, a lot of tools used in Java the world are based on reflection. And typically, if you have your typical Java application, which has, like, say, Spring, Hibernate, and Jackson, each of those libraries maintains its own reflection information, and caches of it. So there's no kind of common way to cache reflective data. Class path scanning can be slow. And I spent, when developing Grails, I spent so many hours and days and time debugging class loader issues in servlet containers. I think, I don't know what the percentage of my time was that I spent debugging class loader issues in servlet containers, but it felt like a lot because of these complex hierarchies of class loaders that typical servlet environments need to support in order to support redeploying applications at runtime and so forth. It was extremely complex, and we wanted to build something where we didn't have the same issues as previous generations of frameworks. And in terms of why reflection is a problem and why it's generally avoided, particularly on Android and mobile devices. A lot of communities, like the Kotlin and Scala communities, completely avoid the use of reflection. And it's more or less because, for a few reasons. One, when you reach in and onto a class and you ask for its reflective data, all of the reflective data for that class is read and cached in a soft reference, essentially. It's kind of an all or nothing deal. You either have, you can't just have one reflective data for one method. You have to have like all of the methods in the class, or all of the fields, or nothing, right? And these won't be GC'd into your application. It's actually on memory. And actually, like loading the reflective data, although I wouldn't say it's slow, but when you do it at scale, it becomes slow. So when you have to load a lot of classes, like in a typical application, hundreds of classes, and traverse through all the methods, traverse through all the fields reflectively, it becomes very, very slow. And we spend a lot of time trying to optimize, for example, Grails to start up fast, and came to the conclusion that it just wasn't possible due to the architecture of using reflection. So reflection was something we tried to avoid, like for the reasons I've already stated, that scanning is slow, the memory consumption is higher, but most modern server-side frameworks do it, and that's why a lot of modern frameworks have been frantically trying to remove the use of reflection as much as possible, because it requires extra configuration for GraalVM native image. So the GraalVM native image came after Micronaut in terms of its development life cycle. And GraalVM native image supports reflection. It does, but it requires extra configuration. So in general, with Micronaut, we just don't do reflection in the framework anyway. And in terms of what Micronaut is, the Micronaut framework itself is microservices and serverless-focused framework, I guess hence the name. But a lot of people associate Micronaut with microservices and serverless only, which is not strictly true, because it's generally it's actually more of an application programming model that's based on annotations. You can use it, and many people do, to build command line applications, to build a variety of different kind of desktop applications. We have one large aeronautical customer using it to build a swing application for dependency injection. But it's basically a few framework fundamentals for building an application. Dependency injection, aspect-oriented programming, configuration management, bin introspections. And it's all based on compilation time approaches. So it hooks into the Java C compiler and by the annotation processing facility, and basically computes the way the framework works during the compilation phase. This makes it. This does mean that there is a small cost in terms of the compilation phase, but it's worth it because what at runtime you get is a much thinner, lighter, smaller executable. And it's also worth it from a developer experience point of view, because a lot of frameworks, traditional frameworks, they fail at runtime with errors, right? So you may be using an annotation here, an annotation there in your Java application, and then you run it and you get an error at runtime because you used the annotation incorrectly. Micronaut fails generally in the majority of cases at compilation time with an appropriate compiler error pointing to the source code in your application where something went wrong, right? So like I said, with Micronaut you can build lots of different things. We have obviously great support for microservices, but there's actually a lot of people also using Micronaut for serverless, particularly on AWS Lambda, although we're encouraging other serverless platforms. But there's quite a few folks that are combining Micronaut with GraalVM to build efficient AWS Lambda serverless applications. In fact, there's one software as a service company that's doing it at scale, and a number of other different companies using it. But you can also just build. You don't have to have a web server with Micronaut. Like I said, it's a general purpose application framework. So there are some, for example, you can build message-driven microservices or message-driven applications. We have really nice integration with a lot of messaging systems, from Kafka to RabbitMQ to MQTT if you're doing like IoT type things. You can build command line apps. And some folks are even using it in the Android space. Every now and then we get an issue report saying, hey, this functionality doesn't work on Android. Can you fix it, please? And we have to change something, because Micronaut is generally not based on reflection, and that makes it good for Android. And traditionally in Android, I believe most people on Android are using something called Dagger for dependency injection with Java. Although I know that's changing with Kotlin and everything, but basically, yes, it's possible to use it inside an Android application as well. Pretty much anything that has a static void main, you can use it with. So that's what I meant by it's a general purpose application programming model. So Micronaut has like different solutions to those various problems that I pointed out earlier. In terms of the limited annotation API, Micronaut at build time will compute the annotation metadata, what we call annotation metadata. Maybe that's confusing for you, but basically it's the representation of the annotations, fusing together repeatable annotations, annotations inherited from superclasses, so that we don't have to scan like the class hierarchy or the interfaces that the class implements to figure out what's annotated with what. And it all just gets computed at build time. So we don't have to do any of that scanning at runtime. And we also pre-compute all the generic information. So in a lot of cases, type erasure issues are easy, and we don't have complex computation to recompute what the generic signature of a particular type is, because that's all computed at build time. Because we know it's a list of string because we can see it in the source because we're processing that. So we just put it in there and it gets used. We don't use reflection, so there's no reflection in Micronaut internals, any of it. So everything is direct method dispatch. That means there's no reflective data caches in the framework itself. Now, we cannot obviously prevent third-party libraries from using reflection. Micronaut cannot make miracles. But in the core framework itself, there is nothing. And all of the scanning is eliminated because basically there's no class path scanning. And there's no dynamic class loading or anything. Everything is just the system class loader. That means that an application, the Micronaut application is very simple at runtime. It's like there's no weird class loading arrangement that can trip you up. And there's no reflections, so stack traces when an exception happens are smaller because it's like direct method dispatch. There's, I don't know if anybody has, how many of you have built Spring plus Hibernate plus, Tomcat applications, but the stack traces are quite infamous for how huge they become with all the reflection and CGlib and whatever else. So stack traces are kept small, the runtime is kept efficient, and we try to address all of those problems. And for me, like the direction in general that the Java industry is going, and there have been subsequent frameworks to Micronaut, one from Red Hat, which I won't mention, which follow the same approach. But generally, the future, the way the Java industry is heading, and even if you look at the way the Spring team are looking to go with Spring 6 and so forth, is towards doing more at compilation time, like doing more during compilation, doing less runtime, making things smaller, more efficient, leaner at runtime. And that's what Micronaut kind of kicked off when it was released and created a big fuss, and everybody was, and still is, excited about it and excited about the way things are going. So yeah. Like I said, GraalVM was was announced publicly after Micronaut, and we kind of built Micronaut with this idea of doing everything compile time, removing reflection, making it simpler at runtime. And then GraalVM came along, and GraalVM is actually a suite of tools. It can be used with the kind of regular JDK as a replacement for the JIT, which is great. So you don't need to go native with GraalVM. If you adopt GraalVM just for the JIT, you may well see, and we have seen in many cases, increase in throughput. But probably what it's most famous for is the ability to take a Java application and turn it into a native executable for the platform that you're running on. So it can do what's called a closed world static analysis of your Java code and transform it into a native executable for the Mac or for Windows or for Linux. That's where it really has the most synergy with Micronaut. It does have many other things. GraalVM has a truffle language framework, and there are implementations of the truffle based for JavaScript and Python, and it allows inter-language communication, and it's generally a suite of different technologies. But what I'll be focusing on, obviously, as part of this talk, is the native image. So like I said, Micronaut and GraalVM have a great relationship, and hence why I'm working at Oracle. And the reason is because basically because Micronaut doesn't do reflection, doesn't do runtime proxy, doesn't have any runtime proxies, doesn't do any bytecode generation, doesn't do any dynamic class loading. It's very simple at runtime. It means it's very easy for GraalVM's native image tool to perform a closed world static analysis on the Java code and figure out that I need how to turn a Micronaut application into a native executable. Now, there's different ways. First of all, I must point out that GraalVM does support reflection, does support runtime proxies, does support even runtime bytecode generation, and it does support dynamic class loading. But you have to provide configuration to native image if your application or any third-party library that you're using does any of those things. So some other frameworks out there, and I believe that's the approach that's being taken with, for example, with Spring Native. They're basically, what they're doing is they're generating all the configuration. So they're leaving the reflection in place, they're leaving all the dynamic class loading in place, and all the other runtime creation of proxies and everything like that. And they're generating config for GraalVM, right? Micronaut is the opposite approach. It's like, do not generate any config for GraalVM and just let it work on a closed world analysis. Yeah, just let it work by giving it a Java application that is compatible with it without additional configuration. So that's why Micronaut and GraalVM work really well together, because the lack of reflection means GraalVM has an easier job, right? And once you compute Micronaut applications into native images, there's significant advantages. There's also disadvantages, and we'll cover some of those. But in terms of advantages, a Micronaut app that's compiled into a native image, at least on my computer, these numbers are on my computer. On your computer, I don't know. But startup time is like 20 milliseconds, as opposed to 600-700 milliseconds for a small app. And memory consumption is like 20 megabyte instead of maybe 80 megabyte on the JIT version. And that means that those those characteristics make it very useful for a number of different scenarios. So you may be building like a command line app, for example. Like Java has really never taken off for command line apps because people expect command line apps to start fast, and they expect them to be native to the machine that they're running on, and they expect them to be, have certain characteristics. So, native image has finally made it possible and viable to create, great native CLIs with Java. Right? That's awesome. I think that's awesome. And there's been a lot of innovation recently in that area. There's a lot of people building great command line apps with Java nowadays, which didn't happen so much before. There is serverless, right? So serverless, in certain cases, there's lots of different types of serverless, but in certain cases, there is the need to start up quickly. It's called the cold start problem in serverless terms. The function needs to start immediately. And if you have a Java app which takes X number of seconds to start, that presents a user experience or an application performance issue. So GraalVM is becoming very popular for serverless, where Java wasn't really even a choice before, right? So before GraalVM, there wasn't. You could write AWS lambdas in Java, but generally people would not because of the cold start performance issues, and maybe the cold start issue wasn't a factor, and you were writing them in Java. But for a lot of use cases, it wasn't viable. And even for cases where Java really didn't have a presence before. For example, you can take a Micronaut app, you can compute it into a native image, and you can run it on a Raspberry Pi, right? That's just awesome, right? You can take Java and applications and put it on an IoT device. Whilst if you run like normal Java, and it doesn't have the processing power to run the full Java virtual machine, right? Or does, but it takes a long time. So there's lots of really great benefits for IoT, serverless, CLI apps, and also microservices. So, I think a lot of Java shops were probably looking, some of them at least, were looking at things like Go, the Golang, because of, let's, deploy the startup time and the association with Kubernetes and so forth. But, you can get the same characteristics in terms of startup with GraalVM native image even if you're doing microservices, or, so there's some real tangible benefits. So anyway, that's enough talk because I don't like talking so much. I prefer demoing. And I'm going to start demoing different things. And first of all, the getting started experience. So right. OK, so first of all, how do you get started with Micronaut? So in my talk yesterday, I actually demoed the really excellent IntelliJ IDEA integration. And IntelliJ IDEA has in the Ultimate Edition, has fantastic Micronaut support. And it's a great IDE. But we also have, and we have at Oracle been building really nice support for Micronaut inside Visual Studio Code. So I thought it would be fun to just today use Visual Studio Code, even though I'm actually more comfortable in IntelliJ. So, but basically, there's a lot of different ways that you can get started with Micronaut. We have a command line utility you can install to create applications, but some people don't like installing additional command line utilities. So it's completely optional whether you want to use it or not. There's also a website. So you can go to start.micronaut.io, and here you can basically choose what kind of application you're building, the version that you want. We support 3 languages. You can choose like Java, Groovy, or Kotlin, and you can choose your build tool. You can choose Gradle. You can choose Maven, and your favorite testing framework. And you can choose which features you want to include when building your application. So, if you like JPA integration, or Mongo, or Kafka, etc., and you can choose the features that you want to include. And then you can generate an application, but you can download it as a zip file, or you can push it to GitHub, or you can check out the commands that you can run with curl to generate an application. And also, like I said, we do have a command line interface, but it used to be kind of required to create apps, but now it's like completely optional. You don't have to use it. But if you do use the command line app, you can also use it to create applications. Otherwise, you can just use curl. And the other thing is it's also integrated into IDEs. So it's integrated into IntelliJ, the ability to create new applications. And it's integrated into Visual Studio Code. So I can come to the Micronaut Tools panel in Visual Studio Code, and I guess I should probably point out the extensions that I have. So I basically have what's called the GraalVM tools for Micronaut. That's kind of a pack of extensions that you want. I also have the Gradle plugin, but basically I have the GraalVM tools for Micronaut installed, and that's the main extension. And what you can do is you can use it to choose your Micronaut version, what kind of application you're building. We have specific integrations for building gRPC applications, or message-driven microservices, or serverless, or command line apps. I'm just going to go with normal application. The other thing it does, the tools, the VS Code tools that we have, is it allows you to install GraalVM SDKs directly from here. So I have a bunch of different GraalVM SDKs. But if you use SDKman, how many of you use SDKman? A few of you. If you prefer SDKman, you can install GraalVM just like any other Java SDK. I can go into the terminal and I can type SDK, install Java, and then there's a GraalVM identifier, and you can install that, and you can manage your SDKs with SDKman, and if you do, they will appear in this list automatically. So I'm going to create, I have GraalVM 22.1 for Java 17. And I'm going to create a new application. It'll ask you the base package, which language you want to choose. So we have support, because Micronaut is compilation time-based, we have to integrate with different language compilers. So for Java, we use annotation processing. And for Kotlin, we also use what's called CAPT, which is in their annotation processing integration. We currently have a project that's moving towards using another thing called KSP, which is Kotlin symbol processing. But it's not finished yet, which will be faster and more efficient, but it'll get there eventually. And for Groovy, we had to write custom integration into the Groovy compiler. And we have an abstraction of all these different languages, ASTs, that allows us to hook into the way they work. But basically, I'm choosing Java. And I'm going to choose a couple of things here. I'm going to choose the Open API support and maybe Swagger, and just basically, well, let's just create a simple app for the moment. I'm going to choose Gradle as the build tool. We have great support for both Gradle and Maven. I'm not getting into a Gradle versus Maven battle. Choose your build tool and be happy with it, right? I think a lot of folks use Maven and are happy with it. And if you use Maven, you should use it. In Gradle, a lot of people use Gradle as well. So, and you get to choose your testing framework. So we support JUnit, Spock, and Kotlin test. I remain a huge fan of Spock. I love Spock. And in fact, Micronaut's test suite, we have a lot of tests for Micronaut. We have tens of thousands of tests for Micronaut. And I would say 80, 90% of them are written in Spock. It's a fantastic testing tool. However, it is based on the Groovy language, and some people are not comfortable with the Groovy language. So for this demo, we'll just do JUnit because it is what it is. Okay, so and what we'll do is just create a Devoxx PL directory, or I think I already did that, and we'll stick it in there. We'll create it. We'll ask you whether you want to trust the application. And now I have a Micronaut project, right? And I get presented with the Micronaut tooling page. So a Micronaut project is just like any other Java project, right? You have a source main Java directory. You have a resources directory with some configuration files. By default, we use logback, or we support logback. That means Micronaut was fortunately never impacted by the recent Log4j situation, but it defaults to logback, and there's a logback.xml where you can configure logging. There is an application.yaml file where you can configure the application configuration. Now, I chose the Open API integration. That's why I have this additional stuff going on here. Other than that, it has an application class. And you can see that we have a main entry point here. We can run this directly inside of the IDE. So I can just click Run here. And my application will start up on port 8080, which it does. And my application is up and running. The main entry point for a Micronaut application, and this is the main method, is normally Micronaut.run, right? Micronaut.run, basically what it does is it bootstraps Micronaut, yeah? And here is a controller. Now, we'll get more into what controllers look like in a minute. But essentially, that is the structure of a Micronaut application. So now for the build, like I said, I chose Gradle. And it's fairly simple in that we have a Micronaut plugin, but all it does is configure the annotation processes and so forth. If I had chosen Maven, I would have a pom.xml where you would define your dependencies. Other than that, there's not really anything special about what makes a Micronaut project different to any other project apart from its configuring, annotation processing, and so forth. That is basically how you get started. So like I said, there's a quick way. The quick way to get started is to go to Micronaut launch, which is start.micronaut.io. You can also use start.micronaut.io's API, which by curl, to create applications without having the command line installed or anything like that. Actually, one other thing I want to mention, the source code for Micronaut launch for start.micronaut.io, it's on GitHub. It's at Micronaut project/Micronaut starter. And it's an interesting project because we take the same code and we compute the code into a command line application using native image for Windows, Linux, and the Mac. But we also take the same application and compute it into a native executable that's deployed simultaneously to AWS Lambda, Google Cloud Run, and Oracle Function serverless. So the start.micronaut.io API that I'm calling, that you can call like in this slide here, is actually a serverless application running natively. So it's a great example if you want to see how you can build a serverless API with Micronaut, right? If you want to check that out. The other way to get started with project is to use IntelliJ and VS Code's integrated wizards. I just used the VS Code one. IntelliJ has a similar one. And of course, if you want as well, there's also a command line utility that's available that you can install by SDKman to create applications. OK, so let's talk about Micronaut Test. So Micronaut Test is a testing library which is part of Micronaut. And we support tests with Spock, JUnit 5, and CoTest. You can check out the project website there. I'm using JUnit 5, and if we look at, I don't know why I keep it. If we look at my test directory here, you can see an example of Micronaut Test. So what happens when you put Micronaut Test on a JUnit 5 or Spock test? Basically, what it does is it starts Micronaut up for that test, and it allows you to use dependency injection to inject components into the Micronaut, into the JUnit 5 test. So I can inject, as you can see, I've got an inject here, jakarta.inject. So this is using dependency injection to inject an interface that's part of Micronaut called embedded application, and make sure that my application is actually running when I start it up. Now, the other important thing to note about Micronaut and the efficiencies that Micronaut introduces to the runtime is how quickly that test executes. So as you can see, the build executes and completes successfully in like 1 second, right? And that makes huge amounts of difference to your ability to write functional tests, yeah, like tests that bootstrap the whole server, because it's as fast as writing a unit test. So we often find in Micronaut projects, people love the fact that you can write lots and lots and lots and lots of functional tests, and they don't take long to start. They don't take away from your build execution times, and they feel like unit tests. And that means that Micronaut test itself is quite simple. It's not a mocking API or a mocking library, or Micronaut doesn't really have mocking APIs because they're not needed. A lot of the use cases I see for mocking is I want to mock this out because it's slow, yeah, or I want to mock this out because it takes long, and I want to keep my unit test fast and efficient. Of course, there's the mocking because I want to exclude this collaborator, and I don't want to involve this microservice in my test, and that's fine. But I also see a lot of mocking just because the thing is slow. So Micronaut tests are really fast to execute and really efficient. And whether you're using Spock or JUnit 5. So the other thing I really like, actually one of the things I do like about the JUnit 5 integration is that here I'm using inject to inject this type into my test. But you can also not use that at all. And I can get rid of that dependency, and I can inject the into the test method parameter. So that's one thing you can't actually do in a Spock. If we're doing a JUnit 5 versus Spock integration. But you can actually inject into the test parameters components of your application, which I think is pretty cool for advantage for JUnit 5. So yeah, it spins up the server, and it lets you interact directly with dependency injection. Now, like I said, Micronaut has got a lot of different components and kind of building blocks that make it work. And one of those building blocks are called bean introspections. So bean introspections, so one of the challenges with the framework is like people write different types, POJOs, if you want to call them, Java beans, if you want to call them. For example, an entity that represents a data transfer object, or a class that represents a data transfer object, or a class that represents the JSON response from your application, or a class that you want to read and write and use as a data carrier from the database. And obviously, like we needed a way to be able to dynamically read those objects, turn them into JSON, read them from JSON, write them into a database, et cetera, but without using reflection. And that's what bean introspections are. So one of the fundamentals of Micronaut are bean introspections. So I'm going to show you, basically, if I just rename this controller to person controller for the moment, and we call this people. And this is what's a web tier controller, where any type that you annotate with that controller, you can define methods that get exposed over a particular URI. And I'll get more into detail into that. But basically, one common use case is exposing JSON here in the response. So for that, you need a way to turn the object into JSON without using reflection. And that's what bean introspections are about. And we have a particular API for it. So what I'm going to do is I'm going to create I'm going to do new from template, and I'm going to say Java, and I'm going to create a record, and I'm going to call it person, like so. So I've got a new record here. And what I'm going to do is we're going to give this a couple of things. This, it's going to have a name. This person's going to have a name, and they're going to have an age. And this represents like a data carrier that you typically send to JSON or read and write to the database or whatever, and so forth. So obviously, like without some kind of way, Micronaut would not be able to do that, right? It would. So what you can do is you can add introspected to any kind of type. In this case, this person, and Micronaut will build, during compilation, a build time introspection, which you can read and write. To see that in action, what you can do is, what you can say is, bean introspection, get introspection person.class, right? There it is. And I have a person introspection. And then I can go introspection, get property names, for example, to get all the different property names, and maybe I can iterate over an array, property names, and just sys out print line name equals name, right? Okay, so this is I'm just writing some basic code to check out that this works. But you can see that that's successful, and down here at the bottom there, it prints out name and age. So those are the two properties. They're not actually properties, they're actually record components. But if this was a Java Bean getter, if I change this to a class and I had name and age properties with getters and setters, it would represent that exactly the same. And the difference is that this is doing it based on build time computed data. So that all of this information is computed at build time, and means we can do certain things without reflection. So for example, I can instantiate a person, Fred, who's 50, and we get Fred back. And I can import in assertions, set equals, I don't know, 50, Fred.age. And that should work. So I can now dynamically instantiate the person class, and it's doing so without reflection, based on this build time computed information. And I can actually now the interesting thing with records is that records are immutable, right? So you can't mutate them, and with introspections we have things like, for example, I can get a particular property, let's call it the age property that is an integer from the introspection, which will return me a bean property for that person that is of type integer. And I cannot set the property on Fred. So if I did this, for example, and try to change his age, I think this would fail. I hope it fails. Yes, it fails. So I cannot. Hold on. No, it fails for a different reason. Is that probably because I'm using? It's probably because this is int. Let's see. Yeah. So sorry, I should have. It's int.class for the property. You can see it says in the error message here, I cannot write a read-only property. So I can't essentially set on an immutable object the value to 40. But with records, what we can do as well is we can say property. I think it is something like with value, Fred, and 40, and then introduce variable changed. And then basically we will get, it'll automatically do a copy constructor approach here to return me the person modified with a new record. So this is one of, bean introspections is one of the fundamental components, the plumbing, I guess you would say, of Micronaut. And this is what we use in Micronaut to implement lots of different modules. So, for example, Micronaut data, right? Micronaut data, JDBC, which is an implementation for JDBC of repositories and so forth, allowing you to read and write objects to the database. It's using introspections under the hood to read, write objects from the database. Even if they're records, if they're Java bean getters and setters, it's using all of that. And that allows the entire data layer interaction to work without using reflection. Right? Without needing reflection, all direct method invocation, nothing required. And we can do this kind of dynamic behavior that you expect from a database access toolkit binding to objects without relying on reflection. OK, so yeah, introspected is basically a reflection-free alternative to java.beans.introspector. So I don't know if any of you have used java.beans.introspector, but it's basically used reflection to do the same thing. And the other thing that I didn't mention is it computes all the annotation information as well. So this introspection actually has annotation metadata, which I can retrieve about the introspection, and I can say, assertions, assert true, annotation metadata has declared annotation introspected, or whatever annotation the class might be annotated with, right? So it provides an API where I can interact and figure out if something is annotated without having to compute, without having to rely on reflection. And it does a lot of clever stuff, because with Java beans, right? With Java beans, not so much with the records, but with Java beans, and actually even with records, it's the same. With Java beans, you have a private field and you have a getter and a setter. But the JavaBeans specification actually lets you put annotations on the private field, or the getter, or the setter. So if you want to have, if you have a like age private field, and it has a constraint on it, a validation constraint, which is at min 18 or something like that, that constraint can be on the private field, the getter, or the setter. And Micronaut will actually normalize that into one view, for that particular property. All at build time, right? So everything at build time, so that like other frameworks out there, they have to go and do all this like normalization and figuring out and computation at runtime, which is like nuts. Like when I look at it nowadays, it's like, why would you do that now at runtime? So yeah, so introspective. Read and write beans without reflection, obtain annotation metadata, figure out, and everything is AOT computed ahead of time. Another interesting fact, which I'm not going to demo, but basically Micronaut can, because it's processing everything at compilation time, it can interpret the value of one annotation as another annotation. So do you know how many, I'm going to bring it up a couple of times in this presentation, but do you know how many nullable annotations there are out there in the Java world? There's like a nullable annotation in every single library. There's like the findbugs one, the spotbugs one, the JavaX annotation one, the Kotlin one, the JetBrains one. There's like a bazillion different nullable annotations. So when you're trying to use the annotation value to figure out, is this field nullable as a framework, it's close to a small nightmare. And Micronaut basically does this at build time by essentially saying, I'm going to transform everything into one view, right? Into one kind of annotation. And does it at build time so that we don't have to deal with it at runtime, which keeps the runtime super light. I won't go through a demo of that. As I said, there's so many different nullable annotations that drives me nuts. And we've fixed that with Micronaut, and we don't have to deal with that. But we also, luckily, whilst the rest of the Java world is in enormous amounts of pain dealing with the transition from JavaX.namespace to Jakarta.namespace, we were like, OK, we just write a annotation mapper that maps JavaX annotations to or Jakarta annotations to JavaX, and we don't have that problem, right? We can transition to the JavaX namespace, to the Jakarta namespace because of the JavaX rename fiasco quite easily. It also provides a lot of useful things. We have a module that lets you use Spring annotations. So you can use Spring annotations like @REST-controller and @getMapping and @whatever, and it just transforms them into Micronaut's view, and everything is the same at the runtime. So we don't have all these runtime checks. If this annotation, if that annotation, if that annotation, we just transform everything to a single view. And we have an in-progress project to support CDI. So we're implementing CDI Lite, which is a container and dependency injection specification. And again, we're just like transforming the values of all the CDI annotations into what Micronaut expects them to be. And it means that if you think about annotations in Java world, it's just like source code level DSL. Then you can transform them into like whatever you want, right? And just interpret them at runtime. It doesn't matter what they are, right? So dependency injection in Micronaut, and I am going to have to start moving faster. 2 hours, you think it's a lot of time, but it's not. So dependency injection in Micronaut is pretty simple. It's based on Jakarta.inject. So for example, if I were to write here a person service type that, for example, had listed a bunch of people, and we can import that, and we can say return list of new person, Fred Flintstone, who is like 50, and maybe we have, another person here, Barney Rubble, whatever. And so we have this person service. So like, how do I make this type a candidate to be dependency injected? So obviously, Micronaut cannot like dependency inject this type automatically because it doesn't know how to construct it. It doesn't know how to like. It doesn't know that it's like a component or part of your application, right? So the minimum that you have to do is have a scope, and that's a Jakarta inject scope. So typically, it's just singleton. So if I just add singleton there, now Micronaut knows to, at compilation time, build a mechanism for constructing this type. And that means it's automatically injectable into other types. Now, I can do this, inject person service, like so. I can do this, and I can say, list the people, like so, and just change. Let me just simplify this to just that, for example. And I can say person service dot list, and I can simplify that, and I can use that inject. But I personally don't like this approach. I don't know. Everybody has their preference. For me, this makes it more likely that somebody's going to try and instantiate this by itself, and then they'll get a null pointer exception because they didn't put this in there, or they'll do something stupid. And I just personally don't like field injection. Each their own, but my definite preference is to do this person service like so, and then to say generate constructor. And now, I just think that's better. I don't know. What do you guys think? I think it's better. That the class is like expressing their requirements of what it needs. It doesn't need an annotation. It's just saying, obviously, I need person service to function. Therefore, it should be in my constructor arguments. Right? So I think that's better. But basically, that's you can do field injection. You can do constructor injection. And basically, they will it will be dependency injected. So how do you make sure something is dependency injected? So with @Micronaut tests, basically it'll bootstrap directly the Micronaut container, if you want to call it. So I can, for example, directly dependency inject into my test here the person controller, and I can say assertions assert not null controller. Well, I guess I can't do that because that's private, right? So I'll just do this for the moment. Probably it's not the, so this is just for demonstrators purposes. So get person service. So as you can see, if I write this and I do this, what happened there? Error cannot find symbol in person controller. I guess I'm missing an import. I don't know why the ID is not. Sorry? Well, I don't know what. The thing is, I don't know what are there. Yes, that's probably why. Thank you. OK, there we go. So run that again. And you can see that basically it'll dependency inject the person service into my person controller. So that's basically how simple it is. Dependency injection, and it works. Now, if you want to know how it really works under the hood, I'm going to comment out Micronaut test here from this test, and I'm going to remove this briefly. Micronaut has what's called an application context, and again, this comes from Spring, I guess, times. I'm a long-term Spring developer, so I just created stuff that made sense to me. I don't know what the hell is going on there. But basically, you can run the application context, which will return you the context. And I think it implements try with resources, so you can shut it down after a period as well, like this. So I can do that. And add import, right? And then what you can do, the application context is like the container object for the whole world. So I can say context.getBean person controller .class to look up any component. So I can look up the controller. I don't know why I would do that, but I can do that as AB. And I can, I don't need Micronaut test to test this. I can run this myself. So actually, for a very long time, Micronaut didn't even have a testing framework. Micronaut test didn't exist, and we just used this approach for testing, and it served us very well for a long time. But people want, it was quite convenient to have like Micronaut test, and the application context serves a whole bunch of other purposes. It allows you to get things like the environment and get a property from the environment, and it allows you to do things like get beans of a particular type, so I could find all of the beans of a particular interface. But generally you don't need to interact with it. You can just use dependency injection like this and keep the things out of your, basically the framework out of your code, and just like focus on your own code, just through the use of like standard annotations and so forth. I know that a lot of people argue that the Micronaut HTTP annotations are not standard, I suppose. And they say, hey, you're not doing JAX-RS, or why is it different to Spring? And, I mean, I don't think they're terribly complicated set of annotations, but if you do really prefer JAX-RS, we do have another project that basically transforms JAX-RS annotations into Micronaut ones. So you could use the JAX-RS annotations and, just be happy, if that's what you prefer. For me, they're just there's a fair amount of commonality between all of these things. It's just an annotation set with at get, at put, at post, at et cetera, et cetera. And if you want to use JAX-RS, that's fine as well. Okay, so I'm going to keep moving because we have to keep moving. So yeah, it's Micronaut DI support. The other thing is that we support obviously the Jakarta.inject, but we also support obviously everything is reflection-free. We know that. I do encourage constructor injection. We're working on CDI 4 support to support more standards. But we also support post-construct and pre-destroy. If you, for example, in this thing here, if I needed to do some post construction initialization, I could init logic here, and if I needed to shut down something, after my, do some cleanup, close threads, clean up here, I can do those, and those again just standard Jakarta annotation, post-construct, pre-destroy annotations, and that's it. So yeah, that's it. The application context, as you saw, it's like a container object where you can interact with and basically retrieve objects and do dependency. Basically, get the objects that you want that are already wired together. We also have support for configuration properties. And that actually works really nice with the records. So, for example, I can have a, I don't know, let's call it a person. We're just going to keep with the person thing. And it can be a record, with string name, int age, whatever. This, what you can do is do add configuration properties on a particular person, like a namespace of configuration, and it will bind the configuration to this type. So, for example, if I come over here, and I'm just going to roll back. Well, I'm just going to put Micronaut test back here, and this back here, and restore that import. and inject my person configuration in here. If I had in my application.yaml person name Fred, age 50, whatever, and I can basically say sessions assert equals Fred, configuration.name, and theoretically this should work, which it does. So basically, I'm binding from my application configuration these values, right? And Micronaut has similar to Grails and Spring, where I can use, for example, I can use an environment variable called person name in my configuration for my deployment, equals Barney or whatever, and it would override the value defined here. Yeah. And that's pretty cool that you have these like type safe configuration options, and it works really nicely with the records in Java 17. It also supports Java Beans, and it also supports interfaces. So you can define actually an interface instead of a record. And so this could be an interface like this, and you could have string get name, get age, so forth. And it also supports default values. So like if I don't want my user to have to specify everything, you can have I think it's called @bindable default bindable default. Why is that not working? I don't know why that's not working. I think it's default value equals Bob, whatever. Default value equals 18, and if the value is missing, it'll inject a default value, right? So there's ways in which you can specify defaults and all sorts of things. Another friend of configuration properties, which I really like, is something called each property. So here we're like binding to a single person for this configuration for whatever reason, but you can also do @each property. And maybe this is called people. And then in my configuration here, I can have people, and we can nest this Fred, Barney, etc. And then we can inject a list of all the person configurations in my application. And obviously, there'll be more than one. So what each property does is it goes and looks at each entry under a particular key and binds multiple of them. So because you might have more than one. So this is how things like multiple data sources work in Micronaut. We have an each property data sources, and you define multiple data sources. I think by default, it expects like a YAML key at the top level, but you can also use like lists, I think, or YAML lists, whatever they're called, like that. And if you specify here list equals true, I think. It's something like that. I think this has to have a value. If you say this list equals true, then you can use the YAML list style to bind multiple things. So that's really useful. Okay, so let's move on. That's configuration properties. And the other nice thing about Micronaut is it's designed to be cloud native so that you can basically make your application adapt to the environment it's working in. And so we have this very dynamic system where you can put bean requirements. So I can say this this bean requires the environment variable food to be set for it to be loaded, right? And you could have another bean that requires bar, and there's all sorts of requirements in here that you can say, this class requires, I don't know, some executor service or something to be present, or that requires another bean to be in the context. So without this shouldn't exist. And you can have like conditional things. You can say, and there's many different possibilities. Common one is properties. So only load this bean if person is set in my configuration, or set some way, or person.enabled, and only load it if the value is set to true, and then then the default value is false, right? So you can create these dynamic components in your application that you can disable and enable via configuration, which allows you to write. This is a really powerful way where you can write, make your application adapt to, okay, I'm running on AWS. I'm running on AWS, so use this, S3 bucket service or whatever. Or I'm running on Oracle Cloud, so use the object storage in Oracle Cloud. Or I'm running on Google, then use something different, right? Allowing your applications to become multi-cloud through bean requirements, essentially. So requires is really powerful. I want to check that out. And that was part one. I think we were running way behind, so those who did miss my Micronaut data talk yesterday might not get to see it in this one, but any of it. But we'll go through some of the other parts of Micronaut. So another fundamental core part of Micronaut is AOP. So it's often called interceptors. I think in CDI they just call them interceptors, but Micronauts is a bit more extensive. We support a lot of the same functionality that things like Spring does, where you can define like advice and interceptors for method calls. So the most famous one in the Spring world, I guess, is @transactional. When you say on the method @transactional, and then it wraps the logic of the method and so forth. So Micronaut has a general kind of concept like that. But it's not based. Spring's one is based on like runtime generated proxies, and Micronauts is based on build time computation essentially. And it doesn't use reflection. It doesn't do runtime generated proxies, and it doesn't do runtime bytecode generation. And everything is direct method invocation. And all of it, so that means like Micronauts' typical useful annotations, things like @transactional, @cacheable, @validated, etc., are reflection free. And related to that, we also have this, because we need cases where we need to execute a method at runtime, and we don't want to use reflection. We have this other annotation associated called @executable that you can put on any method. And it generates like a build time computed method handle for you to invoke that doesn't use reflection and can participate in Graal's closed world static analysis. In terms of AOP, and the reason why it's not just like interceptors like in CDI is because we have different kinds of AOP. So the roots for this terminology has its roots in AspectJ and my time at like Spring and working with Spring. But basically we have two kinds of like around advice is where you want to decorate a method call and add behavior around it. So that's like I want to have this method call and I want to add behavior around it, a transaction, or I want to add logging, or I want to add caching, or I want to add something like that. And then we have another thing called introduction. Introduction is like, I have this abstract type, an interface, or a abstract class, and I want to introduce behavior into it that implements the abstract functionality. So those are the two. There is a third one, which I won't talk about here, which is like adapting an existing method into another interface. But those are the two. So I'm going to do a quick demo of a round advice. But basically, what you do is you say I wanted to add I don't know, logging around this method. What I could do is define a new annotation. Let's call it logged. And I can make this annotation retention runtime. And I can say, it can be target, for example, method. Method, right? And what you have to do is basically meta-annotate the annotation, like put another annotation on top of it called around. At around, right? And that tells Micronaut that at build time this is going to be a method decorator. And then what you can do is create another class called, let's call it logging interceptor. And you make it implement an interface called method interceptor, like so. And you implement that function, the method, which has a single method called intercept. And you can just call context to proceed with the invocation. Now, this is where how you interact with proceed is implementation for specific. Like, for example, the retry functionality in Micronaut calls proceed and then catches the exception and then retries and then calling proceed again and then captures the exception until it eventually meets the retry max retry count, right? Or the caching one will look in a cache and never call proceed, right? So whether you call proceed or not is dependent. But basically, you define this as what's called an interceptor bean, and you say this intercepts the logged annotation, and then we just put system out. I'm not going to do actual logging. I'm logging whatever. And then you come into your code, and you add that annotation to the particular type that you want to it to apply to. And then we can go back to my test here, inject my person service, and call service.list, list all the people, and just run it, and maybe we get to see the output. There we go. So you can see the I'm logging got printed because my logging interceptor was triggered by the presence of the logged annotation. And you can have multiple interceptors that listen to one annotation, right? So, and you can order them, and it's pretty simple. And that's what's cool about it, right? It's all compilation time based. There's no runtime proxies generated that generate huge stack traces. You just implement a method interceptor. There's no runtime infrastructure needed because there's no fancy proxy factory bean or anything like that. It's just really simple. And that's how basically the steps are: you add a round, you implement an interceptor bean, and you intercept method execution and do whatever you want, right? And introduction advice is slightly different. So introduction advice, basically, let's see how we can think of an example here. But basically, say I had another annotation here, and I want to create a testing utility or something like that. And the annotation is called stubbed. I want to, I can again make this, retention runtime, and what I can say that this is at introduction advice, like that, right? And what you can do then is, just follow the same process, is create a new interceptor. Let's call it stubbing interceptor, whatever. That is a interceptor bean. And it's going to check out the stubbed annotation. And again, it's going to just implement method interceptor, the same. And in this case, now the difference between introduction advice and around advice is if I was to call context.proceed here, it would fail with a runtime exception. It would say, you've not provided an implementation, because there's no implementation because it's abstract. So in the interceptor, you have to provide the implementation, right? So how you provide that implementation is kind of implementation specific, but maybe you can get the return type, from the method, and or whatever. And you can say, I don't know, if this is going to be like a bit of a ridiculous example, but is assignable from integer.class, then return 10, or else if arg.getType equals string.class, return junk. Obviously, actually implementing a stubbing library is more complex than what I'm trying to achieve here. What's wrong with that? From something like that. And then otherwise just return null. There would be a more complex implementation in a real world scenario. But basically you can do that, and then say I had an interface here, foo, and it was had one get number, get name, etc. And if I put at stubbed on here, I can inject foo into this method, and if I call like foo.getNumber, I should get, what was it, 10 or something. I should get 10 basically. Okay, just test them out. Whatever. Okay. This may or may not work. We'll see. Cannot invoke int value because, yeah, I don't know if maybe I need to do, maybe because I had it's probably because I've used the primitive form there. Okay, now it passed. I guess I need my stubbing implementation to handle primitive values as well. But basically, that's how easy it is to implement introduction advice. So the difference between introduction advice and around is basically this is providing an implementation to abstract behavior. And that's basically how a lot of Micronauts, things like the Micronaut HTTP client and so forth, work. Okay, you basically, like for example, in the Micronaut HTTP client, you say add client on an interface, and then it has various methods where you can make HTTP calls, and they're all implemented internally with these framework primitives that I'm showing you. There's basically, like in the case of the HTTP client, there's an introduction at introduction and definition on the client annotation, and an HTTP client introduction advice implementation that implements it, and it works, right? So I'm going to skip through some of this because we're running a little time. But basically, Micronaut validation is one of the built-in implementations of AOP advice. So if I had, for example, void, I wanted to save a new person into my service here, and I had like some logic to save a person, I can add annotations here saying this shouldn't be blank, and this should be a minimum of 18, the person, or something like that. And I can add these annotations directly to my service implementation here. And if I were to attempt to call that personService.save method with a invalid value, basically if I call personService.save, and I tried to pass blank, or I tried to pass -10, then it will fail with well, it would fail if I added @validated to the type, right? So yeah, there we go. So @validated is like an example of a advice type where I'm saying that any methods on this type should be validated, and then it will trigger the execution interception of the methods and applying validation rules, et cetera, et cetera. So there are the whole framework ecosystem is implemented in this way: cacheable, transactional, retriable, circuit breaker. Micronaut data itself is implemented as introduction advice, and so on and so forth. So far, I've shown you the different fundamental components, and Micronaut has different runtimes, right? So it has, Kafka for headless microservices, Pico CLI for writing command line apps. You can write gRPC applications. You can write GraphQL applications. You can, we even have support for other frameworks like Ktor in the Kotlin world, and writing serverless functions. But I'm going to talk briefly about the HTTP server. So you've already actually seen the HTTP server in action, because I've been actually running the HTTP server in this example project here, and I have this controller here that has been using it. But basically, you can write full integration tests, for example, using that @client annotation I mentioned earlier. I could have a person client here that lists all of the people, like so, and adds an import there. No, that should be person, sorry. And I can inject this person client into my test, and this will actually talk directly to my HTTP server over. And I think my person controller is going to call my person service, which is going to call into here, which is going to return the two results here. And basically, I can write an assertion that says assert equals to people, people.size. And if I run that, it should pass, which it doesn't. OK, so this is one of the cases where remember I told you about introduction advice, and it's hit an error that says that all possible introduction advice was exhausted and no implementation was found. And that's actually because I forgot to put the @get annotation, so I didn't know what to do with this method. So I'll just add @get. So I want to make a get request that will return all the people. There's an argument that we should make that a compilation error. We probably should. But there we go. So this is a full end-to-end integration test, and it's sending JSON back and forth. And we can add logging to see that in action. I can add a logger in here that logs the io.micronaut.http.client interaction at a trace level, or just the HTTP layer probably. And if I run it again, you'll see the request going back and forth between the client and the server. There you go, you see down there the JSON coming back. So the server itself is automatically bootstrapped when you start up Micronaut test, and also when I run my application from here. But basically, it can also be injected directly. So I can inject directly the embedded server instance in here. Embedded server. And I can obtain, for example, the port of the running server and information about it. I can start up other servers. We allow starting secondary servers and all sorts of things. And you can run it directly. And if you don't want to use Micronaut test, you can run it directly. This is an example of how to do that, just with a try catch block. Controllers, as I said, this is an annotation-based programming model. We support both reactive and blocking operations. And we have full support for reactor and reactive programming model. I already demoed the HTTP client, so I'll go through that quickly. But the whole framework is based on Netty. And you can easily do reactive stuff. So I can say instead of one thing you do need to do is add a particular reactive implementation to your class path. So, for example, if you want to use a reactor, you have to add that as a dependency. And then you can do reactive stuff. So I can say that this should be a flux, and then change that value to a flux. That's a particular reactive type. Obviously, you can subscribe to the flux and so forth, and otherwise you can say, collect list, block, to retrieve the result, right, in a blocking manner. Now, this is not what you would put in production code. In production code, you would want to use Fluent APIs to implement reactive. But anyway, it's up to you whether you use reactive or not. Micronaut is built to support both use cases. Both in the client and in the server, right? So both the server and the client support fully non-blocking. You can also add management and observability really easily to your application. We have a Micronaut management module, which you can add in order to expose metrics, health, logging, information. It's generally locked down by default for security reasons. So when you add it to your class path, there's nothing really visible unless you provide a way to authenticate. So you typically pair it with Micronaut security, which is a security framework for Micronaut, which allows you to do authentication and authorization using JWT or whatever else. But the basic information, like the health point, for example, will return up or down. And of course, if you authenticate and provide a particular role that allows viewing everything, then you get a lot of insight into your application, what the routes are, what the beans are, metrics, what the environment variables are, and so forth. We also have full support for further observability. We have tracing support. We have support today for Zipkin and Jaeger. In Micronaut 3.6, which will be out soon, we're gonna have support for open telemetry. 3.6 will be out in a few weeks' time. And we have support for Micrometer and metrics backends. We also have a lot of support for cloud integrations. So there are modules for AWS, GCP, Azure, and Oracle Cloud, which let you integrate things like distributed configuration, integration with Cloud Vault solutions, serverless integrations with Lambda. We have support in GCP, for example, for pub/sub messaging. There's really a lot of different integrations with different cloud, and there'll be more in the future. So let's get through part 3. And one of the things that more recently that we added is, so the example here where I'm sending the people back and forth here is, it by default is using Jackson, right? And I'm just going to, but Jackson is currently the default JSON library in Micronaut. We have a plugin for Jackson that makes Jackson use Micronaut bean introspection, so it happens in a reflection-free manner. But recently, we launched Micronaut serialization, and it's going to be the default in Micronaut 4. So Micronaut serialization is pretty compatible with Jackson. And in fact, there is a Micronaut, I think it's called Micronaut serialization Jackson, or serialization Jackson. Let me just double check what it's called. So that's one of the things when we have so many different features, but Jackson, serialization Jackson, right? So it's called serialization Jackson. Basically, you have to make a few changes to your application. You have to add a annotation processor, which I'm going to do now. And if you don't know what I'm doing, I'm using a feature of the Micronaut command line called feature diff. And feature diff lets you do a diff on what you need to change to your app to add a feature to Micronaut. And you have to basically comment out Micronaut support for Jackson. And you have to replace it with Micronaut serialization. And there's different flavors of Micronaut serialization. There's one that works on top of Jackson, the Jackson parser without data bind. And there's one that works on top of JSON-P, if you don't want any Jackson dependencies. And as of today, you need to add a bit of configuration because there's a lot of different modules that depend on Jackson, and we're still working to decouple those. But in Micronaut 4, that will be gone. It'll be like completely optional. Basically, once you've done that, once you've added that configuration, if I were to run this again, I think it would probably fail. Let's have a look. Yes, it fails. So one of the major differences between Micronaut, between Jackson and Micronaut support for Jackson and the new Micronaut serialization module, which allows reflection-free serialization and deserialization of JSON, is that, and one of the things it's intentional by design, is that you cannot serialize or deserialize arbitrary objects. In fact, at Oracle, it's one of the great fears of using Jackson because of the various historical security and CVE problems. You cannot just take an arbitrary object and turn it into JSON. It's actually a security feature. So instead of introspected, you actually have to say that this object is certable, which means serializable and deserializable. And you can also say this object is only serializable, in which case it will be serializable but not deserializable. Or you can say this is only deserializable, and you have complete control of an object being allowed to be serialized over the wire. And this provides you more control over what in your application is actually possible to serialize to JSON and back again. And the other thing with Micronaut serialization is it's built on the bean introspections that I showed you before, so there's no reflection anywhere required. And it supports the majority, I think it supports like 90% of the Jackson annotation set, right? There's a few exceptions that we didn't implement for security reasons or because they were too dynamic. But basically, you can use all of the Jackson annotations like JSON property, JSON inline, I think it's called, JSON. All the different Jackson annotations are possible, even things like JSON back reference and to manage circular relationships. And you can annotate objects, and basically, it's not using Jackson. It's using the Jackson parser at runtime. But even if you don't want the Jackson parser, you can use JSON-P, which is a standard, and remove Jackson completely from your application. And obviously, it's very native image friendly because it's not using any like serialization routines at all. So now that I added certable to that type, it's passing. So that's Micronaut serialization, which is a new module that I wanted to introduce first. Essentially a build time replacement for Jackson that eliminates reflection altogether. It reduces memory footprint as well, because we don't have all the runtime reflection requirements of Jackson. It also reduces the size of your Micronaut native image and the size of your jar file. I think Micronaut serialization is like 400 kilobyte, and Jackson is like 2.4 megabyte or databyte or something like that. It doesn't allow arbitrary serialization of objects, so it's more secure. And it's automatically compatible with native image. So we did a lot of work to make Jackson as compatible with native image as possible. And generally, it's seamless, but there's still edge cases of certain annotations where you may need reflection configuration. It's pretty simple. Like I said, you just annotate the types you want serialized, and then you choose a runtime, either the Jackson parser or JSON-P. OK, so let's talk about native image. Now, one of the things that I mentioned that there were still edge cases with Jackson with regards to reflection config. And there is a number of different ways that you can deal with those. But first, I'm going to show you how to build applications into native images. So one of the things you can do is that was kind of nice in the Micronaut tools windows. You can come in here and you can just click build native image, which is quite user-friendly if you like that thing. But what we do have is plugins, right? So in addition to working on Micronaut at Oracle Labs, my team at Oracle Labs are also working on the official GraalVM plugins for Gradle and Maven, right? So there are official plugins now, which they weren't before, and we have some fantastic people from the Java community, like Alvaro Sanchez and Cedric Champer, who used to work for Gradle, working on these like incredible plugins for native image. And Micronaut by default integrates the official GraalVM plugins. So and they come out of the box when you add the Micronaut application plugin. And basically, there's one for Maven, there's one for Gradle, and basically the simplest thing is to build a native image is you do Gradle W, or just Gradle if you already have Gradle installed, and you say native compile. And this will take your application and start building a native image into it. Building it into a native image, sorry. And it will perform the closed world static analysis and basically turn the application into a native executable. Now, native compile is going to create a native executable that is for the machine I am running, right? So that's an important distinction to grasp if you're a Java developer, who are used to the kind of write once, run anywhere scenario, right? So the native image that I'm building now will only run on this Mac. Well, will only run on the Mac, right? Not this Mac, but any Mac, right? It's building a Darwin-based image at this point in time. So I can't take this Darwin-based image and I can't copy it onto a Linux machine in the cloud or on my virtual machine or on AWS and expect it to run. It's just not going to run, right? Unless it was a Mac machine in the cloud. So that's an important consideration if you're thinking about native image, because it's native to that machine and it's not write once, run anyway. So that's one of the disadvantages I discussed before, relatively compared. And the other disadvantage you need to consider is the performance characteristics of your application, right? So native image gives you phenomenally low memory consumption and phenomenally fast startup at the cost of peak performance. Yeah. So the Java virtual machine is awesome for long-running processes that optimize the execution of your application over time. For long-running applications. So if your application is running a long time, the JIT is a phenomenal piece of technology that will continuously optimize the application and make it better. Yeah? Native image will not do that, right? So you have a single, it's basically the AOT process doesn't allow for runtime optimization. That doesn't mean it's slow. In fact, native image is really fast. But there is that trade-off, right? Once you've built a native image, and it gets built into the native compile directory here, you can run it, and I don't know why that popped up. But as you can see, probably that slowed down a bit because of the pop-up, but basically the startup time was 37 milliseconds, as opposed to, I'll show you the Java version in a minute. But the Java version will be like 600-700 milliseconds or something. So, and the memory consumption is also phenomenal, right? So if we look at activity monitor here, and we look for that app, and we go to memory, you can see that the memory consumption here for this app is like, I mean, I haven't put any load on it, but it's like, it's 12 megabyte, which is like tiny compared to to the Java version. So native compile will turn your application into a native executable. And more recently, we've been really hard at work on making testing better for native image. So there is also now native test, which, and I must point out that I'm talking about like the Gradle commands. The equivalent Maven commands are down there as well. We support Maven, with both the Gradle and the Maven plugin. But we also support native testing, which is really, currently it only works with JUnit 5, but it's really great to have a way of like building your tests into a native image and running your whole test suite natively, which is cool, which makes testing a lot easier. Now, to address the issue of building for like a specific architecture, Micronaut's Gradle and Maven plugins also come with the ability to build within Docker. So you can type Gradle W, Docker build native, and it will construct a native image inside of a Docker container using a Linux base image. And that you can deploy to the cloud, right? Or you can push it to a container registry. So if you're using Kubernetes or whatever, you can do Docker push native and push to a container registry. And we also have like Kubernetes integration with Micronaut, where you can say when it will generate automatically. If you select the Kubernetes option, it will create for you the Kubernetes YAML, and you can push your application to K8 packaged within a Docker container, and it's a common popular deployment model if you're into Kubernetes, and some people are. And some serverless platforms have a Docker-based model for packaging and deployment. So you can build a native Docker image. You can push a Docker native image to a container registry, and that's essentially how you build native images. I already done the demo. I can show you how to run those other commands if you want, but maybe in the interest of time, we will just keep going. So the startup memory, these are the kind of numbers that you're looking at. If I didn't actually demo, like if you wanted to build a fat jar instead, you can run Gradle assemble or a Maven package if you're using Maven. And that will package a jar file that you can deploy. And it's just a runnable jar file model. So I can do Java jar build libs demo all, and you can see that, Micronaut is still really fast. It's 680 milliseconds to start up, but it's not native image fast. But anyway, maybe that's not a problem, right? It depends on your your application requirements, depends on what you're doing, right? So that's how you build a runnable jar. And I don't know if we can see the memory usage of that. I probably got like loads of Java processes running. I'm not sure which one it is. It's probably this guy, but I'm not sure what the amount of, I'd have to run PS. But anyway, you can see that's how you build a Java version. And there are some other optimizations that you can do for Java. Java 17 introduced class data sharing, that you can create a shared class package, and that drops startup time to about 400 milliseconds. There's some interesting research going into something called crack, which, again, may help startup time. But really, the state of the art in terms of both memory and startup is GraalVM native image. So dealing with missing reflection data, so if you have a library or you have some part of your application that does absolutely have to have reflection, GraalVM supports reflection, right? In fact, GraalVM supports all the different types of reflection and things like that. You just have to tell it about it. So, if I went to my person class here, and it really needed to be reflectively, what I can do is I can annotate it with reflective access, and the reflected metadata will be generated. Same thing for any like field. So if I come in here and into my controller, and for some reason I need to reflectively access this field, I can just say @reflective access, and it will generate the reflective access for GraalVM to be able to access that field, right? So there are ways to do reflection in GraalVM. It's just configuration. It's just providing input to the tool, okay? And there's also, in the worst case, there's also something called the tracing agent, where you can run your application through an agent, and it will generate the configuration necessary to make it work, right? So you can run a tracing agent, and it will generate all the config. Most simple cases can be dealt with just a few annotations. I'm not sure I'm going to demo that now, given how I'm running low on time. Or maybe I'll quickly do so. So it was kind of a little bit transparent in that I've been this whole time generating my app. When I initially created the app, I included the OpenAPI module, and it's really cool because whilst you're building your application, at compilation time, Micronaut has actually been generating Swagger, which is cool. So Micronaut has a it's all compilation time based, yeah. So we have a module called Micronaut OpenAPI, which during compilation will analyze your source code and generate OpenAPI definition for the application that you're building, which means, again, so many frameworks build complex runtime components to do complex analysis at runtime to expose OpenAPI dynamically at runtime. It's which adds overhead and memory consumption and all sorts of complexity to your application. And Micronaut is just actively generating it for you at build time. We also have the opposite. We recently released support for the OpenAPI generator tool, the official OpenAPI. So you can take an OpenAPI definition and generate a Micronaut application or a Micronaut client or anything like that. Because some teams are schema first and then generate my app. So we're investing a lot in that area, but it's just like another annotation processor. So it continuously builds and produces your Swagger definition, and it's really, really, really cool. So I'm going to skip this because I thought I would have time to demonstrate Micronaut data, but since I did a Micronaut data talk yesterday, I will just give you a general overview of Micronaut data rather than go into a lot of detail. But basically, Micronaut data is a data access solution. So when I started Grails, I really liked Ruby on Rails and an active record and everything it offered, but I couldn't use it because I was building Spring and Hibernate apps deployed onto JBoss or something like that. So I was like, wow, I really want this. So how can we make So how can we make it a similar experience to Ruby on Rails, but like deployed to JBoss? So we created Grails and we created Gorm, and that was the motivation for that. And Gorm was like the first, I think, JVM technology to bring kind of like an active record-like pattern to the Java world, although it was required Groovy. So when I started working for SpringSource, one of the things we were like, what was pretty obvious was there needed to be a Java solution. So we started a project called Spring Data at the time, and I helped out at the beginning to get it off the ground. And I think that Spring Data probably became the most popular or famous, certainly, implementation of the repository pattern of like having an interface that defines book repository and have all your methods. But all of them have the same approach, which is to rely on runtime proxy creation and heavily on reflection and runtime computation. So with Micronaut data, we took a different approach. We thought, wow, we've got this amazing like compilation time framework where we can do so much compile time. So let's move the whole processing of the way the data access repository works into the compiler. So what Micronaut data does is it analyzes your repositories, your interfaces. So if you have book repository, and it pre-computes all the queries during the build process. And that means that it's far lighter weight at runtime, because all of the heavyweight infrastructure to do all that analysis is just not there at runtime. it's like only on the build time class path. And it uses Micronaut AOP, which I showed you earlier. And it's really like pretty much zero overhead runtime database access solution, because there's no reflection. There's just and it's like we have benchmarks where it's like 4 times faster than Hibernate for Micronaut data JDBC, and significantly faster than other solutions. And the other thing I really love about it, which I demonstrated yesterday, is the compilation time checking. I probably didn't demonstrate that enough with Micronaut, but basically, when you make a mistake, you define an invalid query. It fails at compilation time. So it has the whole ethos of the way Micronaut works. And it's really expanding. We started off with Micronaut Data JPA, which is based on Hibernate. Then we implemented Micronaut Data JDBC, which is one of my favorites because it's just so lightweight, and there's none of the complexity of a object relational mapping solution. It's just, I have this Java 17 record, and I want to map it to this SQL, right? It's that simple. There's nothing complex about it. There's no session. There's no there's no proxies. There's no runtime proxies. There's no lazy loading that like confuses you. There's no like all of that stuff that comes with Hibernate, which a lot of people love, but I like keeping my applications lightweight. So Micronaut Data JDBC is awesome, which is the synchronous impl. And then we have a Micronaut Data R2DBC, which you can go fully reactive based on R2DBC and implement reactive applications, reactive SQL applications. And then like a month ago or 2, we released Micronaut Data MongoDB, which is interesting because it's built on, I just showed you Micronaut serialization, and it's built on Micronaut serialization. It uses Micronaut serialization to encode and decode BSON to MongoDB. So it's completely, so all of these implementations, JDBC, R2DBC, and MongoDB are reflection-free, apart from JPA. We can't do anything about Hibernate using reflection. Hibernate is reflection-based, but the others are all completely reflection-free. And then we have a growing ecosystem of other modules. The Oracle Coherence team recently implemented support for Micronaut data backed onto Oracle Coherence. I don't know if you've ever heard of Oracle Coherence, but it's one of the most incredible, underrated technologies at Oracle. It's like a distributed data grid, which I first came into contact with years ago. But it's really underrated tech. So if you're doing distributed data at scale, they were kind of doing what Kafka were doing, but way before Kafka. It's really interesting technology. Yeah, there's different implementations. I will not have time to do the demo. I did the demo yesterday anyway. But basically, each repository interface, you annotate with an annotation, and you can extend from parent interfaces like CRUD repository to do CRUD operations, and you can define finders like find by name, and they all get implemented for you at compilation time. Here's an example of doing CRUD, right? Just save, find by name, update, delete, etc. And luckily, although I didn't get to demo it, we have some really great guides on Micronaut data. So do take a reference of this. I'll give you a minute to take a reference of this, but there's really great guides. And the Micronaut guides in general are awesome because they have sample code with them. So you can download, you can play with the example, and they're in every language. So if you're like Kotlin developer, or if you're a Groovy developer, or if you're a Java developer, we have like great guides for you. So where to learn more, Micronaut docs are awesome. So if you go to docs.micronaut.io, we have a lot of reference material. We have a lot of great APIs. We put a lot of effort into the documentation for the framework. It's all based on ASCII Doctor, and every single snippet that you see is actually a unit test that tests real code. So we try to produce quality documentation, and there's quite a lot of it. And we're doing the same with the guides. So if you go to guides.micronaut.io, there's like guided tutorials in 3 different languages with like Maven or Gradle as an option, with sample code for each guide. And every guide is continuously tested and against each release of Micronaut on GitHub Actions, and it's really quite something on the infrastructure for the guides and everything that the Micronaut community has put into making that awesome. If you want to find about GraalVM, there's like great docs as well about GraalVM, about the native image agent, which I mentioned earlier, about how native image in general. And do follow us on social. There is a Micronaut Framework Twitter account and also a GraalVM Twitter account. So what's coming? Micronaut Framework 3.6 will be out soon, and it's going to be a pretty damn exciting release. It's out in a few weeks. We're going to have a new implementation of Micronaut data called Micronaut data Hibernate Reactive, which is going to add support for the recently released Hibernate Reactive project, which allows you to use the JPA model, but in a reactive manner, to build fully reactive applications. So that's going to be really exciting as another option in the suite of Micronaut data options. We'll be releasing official support for OpenTelemetry. We've been testing it against. We've been testing it a long time, over the past month. It's ready to be shipped, but we're just doing testing. We've been testing it on all the clouds. It works great on GCP. It works great on AWS. It works great on Oracle Cloud. And it works great locally against whatever you're using. So, we're also really excitingly going to launch awesome integration with test containers to basically make it easier to integrate test containers and have like test containers manage your database and that you're testing against. So I think 3.6 will be a pretty exciting release. And then later this year, we'll be releasing Micronaut 4. Micronaut 4, I don't anticipate being a big breaking change from an API perspective. We do need to finish moving to the Jakarta namespace. I think we still have JavaX.validation to switch from there, and JavaX transaction, I think, needs to be switched over. We need to complete that migration, and hence the new major version number. And we're likely to baseline on Java 17 for Micronaut 4. It does mean we will be maintaining the 2 branches of Micronaut 3 and Micronaut 4 for a long time. In particular at Oracle, we have a lot of teams who will be using Java 8 for a long time going forward. So that Micronaut 3 is not going away, but we need to draw a line at some point and support Java 17 only and move the framework forward. And then we have more Micronaut data awesomeness planned. And I think I am pretty much out of time. So just that same reference. And Micronaut framework is great. It makes it a lot simpler, reduces reflection, higher productivity without the performance penalty, and thank you very much. If you have questions, do come and ask me. I'll be around the rest of the day. Thank you very much.